Okay, students, over here with more trigonometry, we're going to add some vocabulary words, angle of elevation and depression. All right, so a lot of just keep practicing what we've been doing, continue to fine tune our skills and get really good at things. So in this first one, if sine of x is 5/13, what is cosine x and tangent x? So with this reference angle, this is the opposite side, adjacent side, and the hypotenuse is always the hypotenuse. So it's saying sine of x, opposite is 5, hypotenuse is 13. Because again, maybe you've memorized it, maybe you haven't, but SOHCAHTOA is kind of our bread and butter in terms of what goes with what. SOHCAHTOA. Sine is opposite over hypotenuse. Alright, so sine of x is 5/13. What is cosine of x and tangent of x? Well, this is where we have to use Pythagorean theorem and solve for a right here. Alright, so a squared plus b squared equals c squared. So we need to find the adjacent side. We know the opposite side, the other leg is 5, and then the hypotenuse, which is always c, is 13. So we have a squared plus 25 squared equals 169 squared. Minus 25 from both sides. We get a squared equals 144. And then you take the square root of both sides. And then a will equal 12. Alright, cool beans. Alright, so then that's 12. Now with respect to this reference angle, angle x, cosine of angle x, remember it's adjacent over hypotenuse, which in this case will be 12/13. And then we can do tan of x, which is opposite, opposite over adjacent, so 5/12. Okay, so that's how you do that problem right there. Just label your picture, use Pythagorean theorem to find the unknown side, and then we can write all the trig functions. Pretty freaking cool if you ask me. Next one, in the figure below, sine of angle A. So sine of angle A, which is going to be opposite in hypotenuse. So sine of angle A equals 0.7. What's the length of AC? So we've never done a problem like this before, but I think we can handle it if you just think about things. What do I mean by that? Well, remember sine of angle A is the opposite over hypotenuse. And then the opposite in this case is 21. The hypotenuse is h. And we know whatever that ratio is, it equals 0.7. So really, we just got to focus on this junk right here. 21 over h equals 0.7. And then we can find h, the hypotenuse, which in this case is AC. Alright, so if I put 0.7 over 1, then cross multiply, I'm going to get 0.7h equals 21. And h is going to equal 30. So kind of a quirky problem. AC is 30. It gave us a decimal as a trig ratio. We knew one of the sides, so it's basically just figuring out what would the side length AC have for sine to be 0.7 if the opposite side was 21. Alright. And then we got some classic trig below. Again, boom, reference angle. This is opposite side, adjacent, hypotenuse. Okay, so then if that's hypotenuse, which trig function uses O and A? Well, that's tangent. Tangent x equals the opposite side over the adjacent side. So plugging in the numbers, we're going to get tan 59 equals opposite x over adjacent 21. Then from here, it's really just a matter of cross multiplying and solving. We're going to get x equals 21 tan 59. Which is about 34.9. Oops. Okay, cool beans. Moving along. This time, we got 40. With respect to 40, x is the opposite side, and h is right there. So remember, which one uses opposite and hypotenuse, well, that's sine, that's the SO in SOHCAHTOA. So sine of theta is opposite over hypotenuse. So sine of 40 equals x over 16. Then it's just putting that over 1, cross multiplying. We're going to get x equals 16 sine 40, also known as 10.3. Okay, cool. All right, and then last one is we got 63 right here. Ooh, what's going on here this time? We got another adjacent side and the opposite side. So it's another tangent one. Opposite and adjacent. So tan of theta equals opposite over adjacent. So tan of 63 equals opposite 13 over x. So realize x can be in the numerator or the denominator. You just must follow SOHCAHTOA. It's not going to always be in the same place. It just depends on which trig function we're using, what side lengths we have, so on and so forth. So then x is going to equal 13 divided by tan 63. Remember, tan 63 is just some number, so that's why we're treating it like just some number. And it's about 6.6. And that's it. Okay, cool. Some trig problems. Traditional trig problems. Now down here, if A is 3 radical 3 in the triangle below, what is the value of B and C? All right, so we have this angle, 3 radical 3. Something we need to do, something I want you to do is say, wait, hold up. That's a 30-degree angle, so this must be 60 degrees. So we have the rules of a 30, 60, 90. All right, I purposely put this in here right after the trig problems because students forget about the rules of 30, 60, 90. They just try to use trig each and every time. So A is 3 radical 3. So remember, to find the hypotenuse, given the short leg, to find the hypotenuse, you just multiply by 2. So C equals 6 radical 3. All right. Then over here, to get to the long leg, that's when you multiply by radical 3. So then B is going to equal 3 radical 3 times radical 3, which you should immediately know radical 3 times radical 3 is regular 3, but I'll show you all the work. I'm being a little extra right now, but it's 9. All right. So what's nice about this is we don't have to use trig, and if we know the rules, this problem takes 2 seconds. And last one, find the value of x below. Well, we can identify this as an isosceles triangle. So this is a 45, 45, 90 triangle. So this is when you're just going to divide the hypotenuse by radical 2 and just get 6. And then that's 6. Okay? That's it for this video. Stay tuned for more.